job that we're going to do today is we are going to isolate the bow thruster number 1 VCB. We're isolating it in order to allow the cleaning of the circuit orifices. Because it's the cleaning of the circuit orifices, it involves us in removing the actual circuit breaker from the cabinet and the isolation that is required for that. To do this, I will use what's called a switching program. It's a pre-written set of chronological instructions which I will follow to bring the actual switchboard to the point where I can issue the permit to work for working on the bow thrust number 1 VCB orifices. The first job I will carry out will be to open the actual circuit breaker. So VCB control, number 1 local close, number 2 local open. And I'm going to take it to the open position from the closed position. Naturally enough, I would first check that the old man isn't using the bow thruster, because there's one thing for certain: if I take it offline and he is using it, he wouldn't be very happy. We will now open the circuit breaker. That's it, to the open position. We're now in the position where we can rack out the circuit breaker to the racked out position. For this, I need a cranking handle, and we will rack out the circuit breaker to the racked out position. We are now ready to open the actual door. We wouldn't open the door whilst making any racking movements, either in or out. Whilst the door's in place, it secures us from any arcing incidents that could happen. Then open the door. We will now remove the secondary supply, or the auxiliary supply. What it does is it puts a 24 volt DC supply onto the circuit breaker to operate the circuit breaker, and it allows communication between the circuit breaker and the protection relay. I'll now remove the auxiliary secondary supply. It's just a plug-in unit, and it affixes to the top of the circuit breaker. We can now bring in the trolley to remove the circuit breaker. Trolley is required because the circuit breaker is quite heavy at 125 kilograms. We will now remove the circuit breaker from the cabinet. Draw out the circuit breaker and make sure it's locked in place on the trolley. Pull the arm across and remove the circuit breaker. That's the circuit breaker out. We're now in a position whereby we can secure the buzz bar shutters. The reason we're going to secure the buzz bar shutters with the danger notice is because they have 6,600 volts, 6.6 kV still on the buzz bars. The shutters themselves, and I'll demonstrate with the cable shutter, can move. The buzz bar shutter can move in a similar sort of way, and to inhibit this we will put a securing lock in place. Next task to carry out is to prove the circuit dead at the cable orifices. To do that, we use what's called a potential indicator. This potential indicator is designed for 11.5 kV, and we check its condition, check that it's clean, we check the condition of the cable, we check the condition of the clamp. We then test the actual potential indicator. We test the potential indicator on what is called a proving unit. This is the proving unit. What it does is it produces a high voltage between this point and this point from a 9-volt battery. When I press the button, you should see the red light come on. We then attach the potential indicator to the proving unit and connect it up, and we should see the xenon lights glowing, and we do. That proves that the potential indicator is working correctly. And we attach the earthing strap to a suitable earthing point, in this case a piece of aluminium on the side of the cabinet. We then bring down the shutter we place the potential indicator in onto the circuit conductors and circuit dead and circuit dead. That's all three phases now tested and proved dead. However, they've only been proved dead because those no xenon lights came on. Now, we could have had the case that the xenon lights broke between when I tested it and when I used it. So to check, we always retest the potential indicator afterwards. We'll do this leaving the earth connection in place and place the potential indicator onto the door and press, and again we have the lights lighting up, proving that the earthing point is a good point and the potential indicator is still working. The task that we've now reached on our switching program is to secure the cable shutters where we have just proved dead. For this we use, again, safety lock with caution notice. Because it is dead, we've just proved it so. We can now apply what's called the circuit main earth. The circuit main earth, what it does is it puts a dead short across all three dead phases and connects them down to earth in order to remove any residual voltage which may be in the bow thruster mode. We have to put a key into this point here. Now, you will notice that when I push this down, there is an interlock. If the circuit breaker had still been in the service position, I wouldn't have been able to clear that. When it's pushed down, I can then put the key in and turn it to apply the circuit main earth. That's the circuit main earth now applied, and it's locked in place with the camera. We can now secure the circuit main earth in place. We apply a multi-hasp with a safety lock, and again a caution notice because it's dead, and that's the circuit main earth applied and locked in place. We're now in a position to close the door across, take the keys outside. We will put the blue key and the black key for buzz bar shutters and the circuit main earth into the key safe outside, which we will then lock. We're going to put the black key for the buzz bar shutters and the orange key for the circuit main earth into the key safe. We will lock it. I, as authorising person, will take one key, and the competent person who's carrying out the work will take the other key and the circuit shutter key. He's now in a position to work, and at this point we can issue the permit to work.